This is lesson 4.4, compositions of transformations, which we've actually already started to talk about a little bit when we talked about translations. A composition of transformations is when two or more transformations are combined to form a single transformation. So we've seen two different translations be combined to form a single translation. But now we can have any two transformations. So to perform a composition of transformations, we first perform the first one. So we take our pre-image, we apply the transformation, and we label our new picture with prime notation, like A prime. The second transformation happens to the new image from step one. And now our second image is labeled with double primes. So we want to know, does the order of our transformations matter for our final image? So will we start and end in the same place regardless of which ones we do? So let's try it. So in our first example, we have our triangle, and we're first going to reflect the line x equals -1, and then we're going to translate it. So the line x equals -1 is a vertical line through -1. So when I want to reflect over it, we're going to count how many spaces it takes to get to the line and just do that many past it. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And then B is up there. All right, so those are our points. So we're going to have -3, 2. Oh, let's be a little fussy now. Well, this is going to take a long time if it does this. -7, 5. And -7, 6. So now our second transformation is actually going to happen to this new picture. And I'm going to translate it x plus 1, y minus 8. So that means every x, we're going to add 1 to it. And every y, we're going to subtract 8 from it. Or we're going to move to the right one and down 1, 2, 3, 4, 5, 6, 7, 8. Okay, so there's our A now double prime, our C double prime, and our B double prime. The next one we do, we're going to do the same thing, but we're going to reverse the order. So we're going to start by finding x plus 1, y minus 8. So we're going to add 1 every x, and we're going to subtract 8 from every y. So we have 2, -6, 6, -3, and 6, -6. Okay, so let's connect these. All right, so that's our B prime, our C prime, and our A prime. So the next thing we're going to do now is we're going to reflect over the line x equals -1. So that's that same line we had before. Over here. So again, we're going to count to the line 1, 2, 3, and go past it 1, 2, 3. A double prime, we're going to count 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. And then our B double prime. So that gives us -4, -6. That gives us -8, -3, and -8, -6. So if I looked at these side by side, I do not end up with the same exact picture, right? I ended up here are my double primes the first time, and these are my double primes the second time. So they are not an exact match. So that means that the order does in fact matter. When you are doing transformations or compositions of transformations, the order that they tell you the transformations is the order that you have to complete them. So you go ahead, try both of these, pause it, and when you're ready to see your answer, hit play. All right, let's check our answers for these two. So we could see our final answers for try one, for both the primes and the double primes, and our final answers for try two, the primes and the double primes. So the next thing we're going to do is we're going to look at a picture that's already had the transformations occur, and we're going to explain what happened. So we have to start with the picture that has no primes on it. So this is actually our first picture. And our picture with a single primes is actually our second picture. Going through the non-primes to the first primes, the orientation, right? Orientation. So if I took a pair of points, I went 1, 2, 3, 4, 5 to the right. So the first thing we had was a translation, x plus 5, and then I went 1, 2, 3, 4 down, so that's y minus 4. The second thing I did is a mirror image. So this is a reflection. And these two are 2 spaces apart, which means 1 space apart where our line is. So that's a reflection over the x-axis. So you're going to try this one, pause, and when you're ready to see the answer, hit play. All right, here's our answer for that try. The first thing was a translation down 4, and then it was a reflection in the y-axis. So the next thing we're going to look at is they give us a figure, and they want to know which two of these compositions of this figure will result in the image being only in the first quadrant, so entirely within the first quadrant. So our quadrants go 1, 2, 3, and 4. It's almost like a C for the word quadrant. So let's run through all 4 of these. And I've already done all the work here. So if I were to translate 6 units to the right and then 2 units left, that's overall really just 4 units to the right. And that would put me solidly into quadrant 4. Oh, I wrote quadrant 2, quadrant 4. So that's not going to work, right? Quadrant 4 is not quadrant 1, so that one's out. The next one is a reflection across the line y equals 4. So the line y equals 4 is up here. So my final picture would be way up here. And then moving 5 to the right. So as long as I'm moving j over enough spaces to cross the y-axis, that works. So that is one of our compositions. The next one is a reflection across the line y equals negative x. So that's this line here. So that would put us here first. And then just up 1. So that's not going to be enough to move us all the way into quadrant 1 if it only moves up by 1. So that one's out. The next one is a reflection across the line x equals 3. So I've drawn that here in green. That would put our picture somewhere around here. And then I'm moving it up 8. So as long as E is moving up far enough to cross the x-axis, that one works. So that is our second answer. So 2 and 4 are our answers. And just to be sure, let's check number 5. A reflection across the x-axis would put our picture around here. And then moving it up 13 still keeps it along the y-axis, right? It's not fully on one side or the other. So that one does not count either. So we've been talking about congruency quite a bit. So congruent figures are congruent if there's a single transformation or a composition of rigid transformations that will map one onto the other. Congruent figures have the same size and shape. Their sides are congruent and their angles are congruent. So in this picture, I can identify figures that are congruent based on the translation and reflection of orientation that separates them one from the other.
is congruent, and I'm going to match up CB, AJ, and QB, and R. And that's by, so see the translation, I went from left to, oh, there I go, translation, and it's x minus 2, and then 1, 2, 3, 4, 5, 6, so it's been 1, 2, 3, 4, 5, 6. Those 6 gaps. So looking for another pair that's congruent, it looks like 6 and 1 are. And I can actually look at this two ways. It can either be a rotation of 180 degrees or a reflection of 180 degrees.
So let's use the rotation.
So I have an angle J on the H is congruent to J is actually to UTX, and that's by a rotation of 180 degrees about the origin. And our last set, numbers 3 and 4, also look like congruent. They have sides 3, sides 2, so they match. And that looks like a reflection of one of the other. So I can say triangle FCG is congruent to triangles that are started up here, L, L, and M. And that was a reflection in the X.
So as long as you can find a transformation that will bring one to the other, those figures are congruent. So you're going to try the last set, pause it, and hit play when you're ready to see the answer. Okay, so in this picture, it looks like 4 and 5, or triangle LKM, would be congruent to triangle TSU, and that's by a reflection in the y-axis. Quadrilateral IHGJ would be congruent to quadrilateral KPNR by a translation x, comma, y minus 6. If I had flipped the order here, I had KPNR first, and then IHGJ, that's going to be x, y, first. So it all depends on which thing you put first, and how you got from one to the other. And then triangle SED would be congruent to triangle CBA. So again, I'm starting at SED, I'm going to CBA. So I'm saying that rotation about the origin. I also put in 270 degrees counterclockwise. And that is compositions of transformations.